15.7 talks about triple integrals in cylindrical coordinates. Well, cylindrical coordinates have the polar and z is z, so not much difference. If I'm given x and y, there's my x, there's my y. Well, we know that's a right triangle, and we know that r squared equal x squared plus y squared, and if the angle is given right there, tan of theta equals y over x. If I'm given r and theta, then I know that x equal r times the cosine of theta and y equal r times the sine of theta, and they're all right there. So if we want to plot a point, remember this is the positive x-axis, that's the 0, positive rotation, negative rotation. So we rotate 2 pi over 3, that's in quadrant 2. We'll line up 30 degrees from the y-axis, and we move 3 units in that direction. 1, 2, 3. That's kind of like me rotating the 2 pi over 3, and in that direction moving 1, 2, 3 units. And z is 4. That means you're going to go up, straight up, 1, 2, 3, 4. And you're right there. If I want to convert, well, z is z. This is still 4. So basically we're saying if r equal 3 and theta equal 2 pi over 3, then x equal 3, the cosine of 2 pi over 3, that is 3 times negative 1/2, so that's negative 3/2, and y equal 3 times the sine of 2 pi over 3, that is 3 times radical 3 over 2, so that is 3 radical 3 over 2. That would be the equivalent rectangular coordinates to that point, and there it is. And if I'd like to plot the next point on my list, I would rotate to 5 pi over 4, that is 3 pi over 4, 5 pi over 4 is lining up right there. And I move 1, 2, 3, 4, and since this is negative 3, I move down 1, 2, 3, and here I am. So that's under the floor. Well, if I want to convert that, this is r, theta, and z. That will also work out to be a negative 3 for z. If r equal 4 and theta equal 5 pi over 4, then x equal, for the cosine of 5 pi over 4, remember 5 pi over 4, in this quadrant they're both negative, so that's 4 times radical 2, negative radical 2 over 2, that's negative 2 radical 2, negative 2 radical 2. Okay, I don't know why I squished that. That is negative 2 radical 2, negative 2 radical 2, and negative 3. So this is the same location using x, y, and z. And given a point in rectangular coordinates, so if I am to move 3, 4, I'm right there. Well, that's the same as 4. Z doesn't change, but instead of x and y, I want r and theta. And I noticed on the 2 dimensions that is really 3 in the x, 3 in the y. There's r. So if I move 3 in the x and 3 in the y, that's actually the square root of 9 plus 9, that's the square root of 18, or 3 radical 2, and theta is pi over 4. I don't even need a formula for that. And if I wanted to plot the point 0, negative 3, 3, so 0, negative 1, negative 2, negative 3, 1, 2, 3. Again, that's really 3, 4, z, that doesn't change, but I want r and theta. Well, theta is rotating pi over 2. Oops, I'm sorry. It was, I messed up. Y was negative 3, not 3. So if I move 0, 1, 2, 3, and go up 1, 2, 3, I'm right there. So this is the triangle that we're looking at. Well, rotation-wise, I'm going to rotate to 3 pi over 2, and I'm going to move 3 radical 2, because this is square root of 3, 9 plus 9, that's radical 18, which is 3 radical 2. I left the theta as radical 18, but if you simplify it, that's what it is. We sketch the graph of the cylindrical coordinates. If they told us theta equal pi over 3 pi over 4, so there's no r and there's no z. Well, let's see how this works. I rotate to 3 pi over 4. 3 pi over 4 is located right there. And if r is 1, z could go up and down. R is 2. So what that does, that creates a plane. If r is negative, we didn't set r to be positive. So I get a plane that's cutting at 3 pi over 4. Z runs all the way up, all the way down, and R runs all the way forward and all the way backwards. And if I'm trying to sketch a graph of this, well, I know what that looked like in 2 dimensions. In 2 dimensions, it doesn't say, it does say find the equivalent. Okay, I left that part out, so let me shrink this a bit then. There's the graph. And if I want to convert that, sketch each graph and find the equivalent rectangular coordinate. Well, I know that tan of theta equal y over x, because I want the rectangular. Tan of 3 pi over 4 equal y over x. Negative 1 equal y over x. So I could say y equal negative x. And since there's no z, you take the line y equal negative x, which is this line, and z would run vertically, creating the plane. Here, I know what that graph looks like. On 2 dimensions, I know this looks like this. It's a circle wrapped around the positive x-axis, because that's a cosine, with a diameter of 4. On the 3D, I can sketch a graph. So that right there is really that right there. And that's an infinite cylinder because there's no z. If I want to convert, I will say, well, let's see, multiply by r. R squared equal 4r, the cosine of theta. X squared plus y squared equals 4x. x squared minus 4x plus a number plus y squared. Take half of the middle number, which is 2, and square it. And I'll get x minus 2 squared plus y squared equal a 4. A circle with a center of 0, 2, with a radius of 2 to the right, 2 to the left, 2 up, 2 down. There it is. So that's the equivalent rectangular coordinates. A circle centered at 2, 0 with a radius of 2. Alright. Sketch the graph of the rectangular surface and find its equivalent. So the goal here is the graphing. Can I sketch a graph of this? Well, yeah. Z equal x squared plus y squared. I know that's a circle. But there is no z, which means it's going to run up and down, creating... Oh, take that back. Z equal x squared plus y squared. This is one of those. Right, it's infinite. Find its equivalent cylindrical coordinates. Well, that is z equal r squared. That's it. If it was a radical, that would have been a cone. That's not bad. How about this? This is a plane. We know what that looked like. Right? If I want to sketch a graph, well, I could. And the graph is a big deal for what's to come. So I notice that this is, if x and y are 0, z is negative 6. If y and z are 0, x is 2. And if x and z are 0, that's a 3. It's a plane that's intersecting the xy, xz, and yz plane in that form. And this is 3r the cosine of theta plus 2r the sine of theta minus z equals 6. You could solve for z if you want. You don't have to. That's good enough. Alright. And if I wanted to look at the next 3 problems, so let's see how this works. Triple integrals using cylindrical coordinates. So what this says, go for the 2D first. Get the r and the theta out of the way. If I say r runs from 0 to 3 and theta runs from 0 to pi, well, 0 to 3, let's say this is 3. Theta runs from 0 to pi. They're talking about this part. Right? Now I notice that z runs from 0, so negative 3 on the x, and 3. Something like that. Now, z runs from 0, from the ground, to r. Z equal r, that's z equal the square root of x squared plus y squared. That's a cone. So I get a mimic of that right there. And z simply runs from the floor to that. So this right here is empty. It's hollow. You're going to only get this part right there. Like half at the kilaka. How about this problem? What does that look like? Well, again, look at r and theta and see how that works. Well, theta runs from pi over 4 to pi over 2. Okay? R runs from 0 to 4. That's 4 units. And z runs from 0 to 3. So that's like a piece of pie. Use cylindrical coordinates. Evaluate. I'm going to set up the integral. Well, again, the graph is a big deal. This is saying z equal 5. 1, 2, 3, 4, 5. But then I'm going to cut it off at z equal 1. So we're talking about this solid. Well, the triple integral over region E of x dv is going to be using cylindrical coordinates. That is r the cosine of theta, r dr, r dz, dr d theta. Well, let's see. Theta runs from 0 to 2 pi. R runs, well, z runs from 1 to z equal 5 minus r squared. And if I look at where those intersect, pretty much dr d theta, if I put the 1 right there, I'll be looking at 1 equal 5 minus x squared minus y squared. If I move those to the left and this to the right, so I have a circle with a radius of 2. 0 to 2 pi and 0 to 1 will do the trick. I'm assuming you will evaluate those. If not, I'll be more than happy to go over that in class. How about this problem? What are they talking about? They want a circle between 1 and 3. So they want this region. And this is going to create, of course, kind of like a washer back in the days. You remember doing something like that in calculus? Now this is going to be cut off by this plane at 5, but it's going to cross y at negative 5. So it's going to take this plane is going to run and it's going to look like this, because this is going to keep on running up. So eventually it's going to be cut by the plane. And so think of a cylinder, and you get a laser and you cut straight across. That's kind of what it looks like. Well, we want the triple integral over E of z plus y dv. That's going to be the triple integral. Well, z is z, r the sine of theta, of r dz dr d theta. Now, once I figure out that z runs from the ground all the way to z equal y, that's an ugly sign. Plus 5. Then I'm looking at this on the floor. This is going to rotate from 0 to 2 pi, and r is going to run from 1 to 3 all along. And that would be the volume of that solid. And almost done. If I look at this problem, I want to convert. Well, how does that work? I can't just say, oh, look, one of those I can get. I can get r dz dr d theta, but I need to know what that region look like. And I know what this is. This is r cosine of theta minus twice r sine of theta. Actually, I'm going to put that right there. Now, if I look at the graph, how does that work? First, let me get the 2 dimensions out of the way. This way I could really get the 3 dimensions. I'm looking at y running from y equal negative 2 to y equal positive 2. And x runs from 0 to this half of a circle. So y runs between negative 2 to positive 2. And x runs from 0 to x equal 2 toward the positive x-axis. That region. So this region should continue. And I noticed that z runs between 0, which is the floor, 1, 2, 3, 4, 5. And there it is. Half a cylinder. Well, that's easy to do. If I really look at this, I know that z runs from 0 to 5 still. That's not a problem. But now I'm looking at this using polar coordinates. Well, can't you say that the angle runs from negative pi over 2 to pi over 2? And r runs from 0 to 2 all throughout. And that would take care of business. And that would be it for this section.